Good morning, friends. Today we discuss about the electropositive characters of P-block elements. Electropositive characters. If we discuss about the periodic tables of four block elements, that is S, P, D, and F block elements, most electropositive elements are the S block elements are most electropositive elements. Then, if you go from left to right in the periodic table, continuously the electropositive characters are decreases. Electropositive characters are decreases. And the here in this case we discuss about most electropositive elements are present in the S block elements, and if we go from left to right in the periodic table, the electronegative characters or electronegativity is increases from left to right in the periodic table. The fluorine is present in the halogen series, and the fluorine having the most electronegative element in the periodic table, and cesium, which is present in the group first alkali metals, this is the most electropositive element in the periodic table. Fluorine is the most electronegative element, while the cesium is the most electropositive element in the periodic table. Today we discuss about the electropositive characters of P-block element. What happened? The redox potential, most of chemical reactions are carried out in aqueous solutions. Redox reaction means, here in this case, the reduction as well as the oxidation reaction which takes place, that reactions are known as the redox reactions. And the most chemical reactions are carried out in the aqueous solution. It means that the hydrated water aqueous solutions, the oxidizing and reducing properties of the element in these solutions are better understood in terms of standard electronic potential, that is the capital E holds the more electropositive the value of oxidation potential, the greater is the tendency of metal to ionize. If the more the value of positive value of oxidation potential, then greater is the tendency to metal to ionize, the greater is the power to act as a reducing agent. Similarly, the powerful oxidizing agent had a large electronegative value of oxidation potential. Here in this case, if we discuss about the aluminum having, if the three molecules are ionized, aluminum tripositive, oxidation state of aluminum is 3, and if the 2 electrons are removed from the S, if the ionized fluorine, what happens in case of the fluorine? Here in this case, the fluorine negative, it means that the 1 ions is formed. If the fluoride is combined, then the formation of one molecule of the fluorine, that is F2, is formed and releases, that is the minus 2.80 volt, and this is the equilibrium reactions. Here in this case, there is the reversible reaction is formed, and aluminum, if the 3 electrons are removed from the aluminum, then the electronic potential value 1.70 volts, and Here in this case, the aluminum act as a powerful reducing agent. Here, aluminum is act as a powerful reducing agent, whereas the fluorine act as a powerful oxidizing agent. Yesterday we discussed about the oxidizing agent and the reducing agent. The oxidizing agent is the substance which can take up the electron. Oxidizing agent which can take up the electron, and while the reducing agent which can supplies the electron or which can reduce the electron. These are the oxidizing and reducing agent difference. Here in this case, in the example of aluminum ion fluoride, the aluminum is most powerful reducing agent, which supplies the electron, and oxidizing which can take up the electrons. So this is the oxidizing and reducing agents and how the oxidation potential, which elements having the electropositive or the electronic potential, or in this case the electropositive characters of the elements. If we consider about the, here in this case, more the positive value of oxidation potential, greater is the tendency of metal to ionize, that is the greater is the power to act as a reducing agent, Here in this case, the aluminum having the positive value of electronic potential, it means that the oxidation potential is greater, and metal to, and greater the power to act as a more reducing agent, and the value of electronic potential value of fluoride is less value. It means that here the oxidation potential is less, and the less value of the electronic oxidation potential, and the less tendency to metal ionize. So here in this case, the aluminum is act as a most powerful oxidizing, aluminum is most powerful reducing agent, that is the reducing agent which supplies the electrons, and the fluorine is the most oxidizing agent. It means that the oxidizing agent which can take up the electron, and while the reducing agents which can gives the electron. So this is the electropositive characters of P-block elements. Generally, all the halogens, fluorine, bromine, and iodine are the most powerful oxidizing agents, and the metals, that is the aluminum first group element, second group element, as well as in the P-block elements, group 13th element. These are the most reducing agents, that is which can gives the electrons, and all the halogens are which can take up the electron. That's why the oxidizing power is greater. That is, the greater is the power to act as a reducing agent. Similarly, the powerful oxidizing agent had large negative value of oxidation potential. And the most powerful reducing agent have the oxidation potential value is positive, and the most oxidizing agent having the more negative value of oxidation potential value. So this is the difference between the reducing agent as well as the oxidizing agent. Reducing agent having the positive values, and reducing agent having the positive values of oxidation potential, while the oxidizing agent having the negative values of the oxidation potential. So this is the electropositive characters of the p block elements.